Now we're going to go backwards and we're going to write the equations of the given lines. But we're using the same concepts, the same pieces of information. So let's look at our line here and let's first determine where does that line cross the y-axis. Well, this is where the line crosses the y-axis. In other words, a y-intercept is 0, 1. That means that b is equal to 1. And let's look at our slope. For the slope we need 2 points. Why don't we take the y-intercept we already have and pick one more point and see what happens here, how to get from one to the other. We need to go down 2, that means -2. So m is equal to -2. And then we go 1 to the right, 1. M is equal to -2 over 1. So that is what we found out. And now let's put that into our equation. Remember our equation in slope-intercept form, and that is really the easiest one to use when we write an equation. Sometimes we have to go one step further and then change it and turn it into an equation in standard form. But the easiest one to get an equation going here is to use slope-intercept form, because we can pick the slope and the y-intercept directly from the graph, and then we plug it into our equation. So y is equal to mx plus b is our slope-intercept form. Instead of m, we're just going to write now -2. Don't forget the x. And our b is +1, so we're adding 1. And this is the equation of the line that we see up there. Let's go to our next example. All right, so what is our y-intercept? The y-intercept is right here, and it has the coordinates 0 and 0. In other words, b is actually equal to 0. And let's look at our slope. We go 1 up, 1 to the right. M is equal to 1 over 1, or just equally is equal to 1. Let's write our equation then. Y is equal to mx plus b. And now it gets interesting, because what are we going to put in the place of m? Well, 1 should be the number, right? But we don't really need to put it. Let me put it down just to show you. 1x, and then we have b's equal to 0, so we have 1x plus 0. And now you see that there's a lot of stuff in this equation that we don't need to write. We don't need to write a coefficient of 1, so we just write y is equal to x. And we also don't need to write a constant of 0. If we're adding 0, we're adding nothing. And then this is our equation. Y is equal to x. That's actually, as you can see, the diagonal, the first diagonal going through our coordinate plane, and that has indeed the equation y is equal to x. That means that every y value is exactly the same as the corresponding x value. Isn't that nice? Okay, let's look at our next example. We're all getting towards the end here. We have a line that looks horizontal to me, and when I say horizontal, I remember hoi. And why is that important? Because hoi tells me that now I'm only going to have an equation with a y in it. Y is equal to a number. There's not going to be an x that I need. And what is that number? I've used green so far for a y-intercept, so I'm going to keep doing that. Here is our y-intercept, and that number happens to be +2. So the y-intercept is 0, 2, and our equation is y is equal to 2. See, that's how quickly it can be done, remembering hoi for horizontal lines. And you guys knew it. We also have to talk about, or also want to talk about, vertical lines. Vertical lines make us remember bucks. and Vux stands for vertical, undefined slope, and X is the only variable. X is the only variable because this line does not have a y-intercept. We only are interested in finding out what is the x-intercept. From what I can see, this is the point -3, and therefore I'm going to write the equation x is equal to -3. And that's that, guys. Remember, Heuwachs, they are very helpful little mnemonics, and they can help you whichever way you have to deal with horizontal and vertical lines. All right, for your summary, I would like you to explain how using the slope-intercept form is similar to using the point-slope form when we are graphing a line. Have fun writing your summary, and I will see you in class.